you know, unless you already understand objects and object-oriented programming, we're really kind of laying the foundation for what is an object, what's a class, how do they relate, and how do we use them in Java. So this is the stuff that you'll be using every time you do anything related to this course. So it's good stuff to be here for. So any questions from what we've done so far? We were sort of starting to play with some classes, and we set up main programs, and I teased that I was going to talk about accessors and mutators today. So let's go ahead and do that. So we're going to make a rectangle class. So this is our main method, public static void main as usual. I'm just defining R1 to be a rectangle and I'm setting its length to 7. And our rectangle class will just have a width and a height of a rectangle. So it's just kind of a placeholder, like a structure. So I can compile those up. Call it width and height. And so do you remember what we have to do besides saying rectangle R1?
We have to call it new.
Yeah, we have to construct it. We have to use new. So I can do that on this line, or I could say R1 equals new rect. Just like malloc, we can put it on the same line that we declare the variable, or we can do it later on. So that should keep everything happy, and it doesn't do anything because we're not printing anything, but it constructed a rectangle that set its length, and that's good. All right, so so we'll throw a diagnostic print statement in here which prints out length equals, tacks the length on, prints out width equals, tacks the width onto that.
That's pretty powerful.
That's very powerful, definitely. We don't have to do the %d stuff that we do with printf. It will intelligently take the length and look at it and know that it's a double, and it'll turn it into a set of ASCII characters and concatenate them. That's what the plus says to the end of the string, length equals. And so if we run that, I wish I could remember what I normally call these things, because I seem to switch between length and width and it's like tripping me up. But we'll figure it out. So length equals 5.0, width equals 7.0. And I put the 0.0 because I said they were double, so it's doing that. So it looks like a double instead of an integer. So that's all fine. Our rectangle class contains two things, two variables, a width and a height. Remember I said when we have classes, the whole deal is that it's like a struct, but we can also include code. So we can actually have executable code as part of the class. So let's make an area function. So I'm going to say public because I want things outside of this class to be able to access this function that I'm about to write. And this function is going to return a double. And I'm going to call it area. And I'm going to pass two arguments to it, which I'm going to call h and w. And how do we find the area of a rectangle? Pop quiz. Height times width. So that's not too terrifying. So area is a function just like a C function. It takes two arguments, it returns the product. All right. All right, so all right, so after I print out the height and the width, I'm going to print out area equals, and I'm going to call that area function, and I'm going to pass it the dimensions 5 and 7, and it should calculate the area, and then print that out. Yeah?
Can't you also pass R1 dot width? And
We
R1
could.
dot height?
So we're going to do that next. All right, so area equals 35, not terribly surprising. So yeah, let's do what Connor just suggested. And let's print out R1 dot height, comma, R1 dot width. Right, so we get the same answer, 35 for the area. But we didn't have to hardwire these magic numbers 5 and 7, we just used the height and the width. Well, that's not bad. That's something that we would see in a C program. Right, here's an area function, here's an insert node function or whatever, and we pass arguments and it does something and maybe returns a value. But if you look at what we've got here, we're calling this area code and we're saying run the area code that's contained inside this object R1, right? And then we're passing it other things that are contained inside R1. If instead of passing it the height and the width, we somehow just passed it R1, right? Our code could grab the height and the width from R1. But in fact, when we say R1.area, we're running this set of code called area, but we're doing it kind of inside this R1 object. And this is a little weird to get our brains around sometimes, but it's like we're saying R1 is a rectangle. So we can think of R1 as this thing, this object, that has a height, and it has a width, and it has some code called area. And if we say rectangle R2, then R2 is a separate object that has its own height and its own width. And we can think of it as having its own area code. Now the code is shared, so it's not grossly inefficient. But we think of this as something that has three things associated with it, two doubles and a function. And R1, same thing, two doubles and a function. So when we're inside this area function, we got here through this object R1, or we got here through this object R2. So inside this function, if we were to use the variable width, it would refer to this double, but it would actually refer to R1.width if we said R1.area. If we said R2.area, then width would be the same thing as R2.width. If we invoke haha.area, then width is haha.width.
Does that mean that we don't necessarily need to place values inside area when we call area?
Correct. That's exactly what it means. We don't need to pass anything to area because it's specific to that object, exactly. So we can do this.
And that's object-oriented.
That's object-oriented. And that's something we also call encapsulation. It's putting the code and the data inside this single thing. And now our code has access to it. So this right here is one of those big kind of mental turns in the road, right? If you can grok this and at least live with it until it really clicks, right? This is a fundamental object-oriented thing. So we can just say return height times width, and it means the height and the width of whatever object we use to run this area code. So let's try that. Well, let me keep commenting out. So let's just print r1.area. Alright, so area is 35.
I noticed on tutorial's point it had SystemOut.print.
Mm-hmm.
What's the difference between SystemOut.print and SystemOut.println?
Println means print a new line at the end.
Ah.
So it's like putting in the \n. So if you just say print, it'll print out, but it'll stay at the end of that line. And then if you say print again, it'll continue on the same line. So println is like print with a \n at the end.
What's the other way to do a new line, if there is one?
\n.
Just \n
Yeah.
still? Oh, cool.
Yeah, that'll still work.
Yep.
All right, so now we're constructing another rectangle R2. We're making that a 10 by 20. And we're going to print out R2's area as just R2.area. And so R1 is 35, R2 is 200. So one advantage of this is we don't really want to call an area function and pass it a height and a width every time we want to find the area, because we got to know what the arguments are to area. We got to know what the order of those arguments are if the order matters. We got to know what that area method basically does, right? And if somebody wrote this rectangle class for us and handed it to us, we'd like to be able to just say, okay, here's a rectangle, tell me what the area is. Well, you have to call this function, and your first argument has to be this, and your second argument has to be that, and so on and so forth, right? It really shouldn't be like that. All of those details should be handled by the class itself. So we make area a piece of the rectangle class, and we just say, give me the area. And internally, it can do whatever it needs to do. Okay, so encapsulation, putting the code and the data together, basically. And this also gets us to the idea of information hiding. So, so let's do something. Anybody ever play with like straight edge and compasses? So the Greeks studied this question of like, if you take a compass, right, it's just a thing that you can use to draw circles, basically. You can set the diameter. And a straight edge is just, it's like this. It's a ruler, but there's no marks on it. So you can't measure distances, but you can draw straight lines. And the question is, what kinds of things can you do with just a straight edge and compass besides stabbing your classmate in the arm? And you can draw 90-degree angles, right? You can draw circles, obviously. You can draw half a circle. You can make a 60-degree angle. But there's some things that are very difficult to do. So one thing that the Greeks wanted to be able to do was square a circle. Draw a circle, and then draw a square with the same area. And it turns out that's impossible to do. Another thing that's impossible to do if you're given an angle is figure out how to draw a trisection of it. Cut the angle in a third. You can cut it in a half, you can cut it in a fourth, but it's been proven you can't cut it in a third. Okay, but something that's fairly easy to do is squaring a rectangle. So here's a rectangle, and let's say it's 2 by 8. I don't know if this is actually doable. I'm going to say it is. Squaring this would mean, well, here's another rectangle that has the same area. The area up here is 16. The area here is also 16, but this is a square. So if we're not restricted to straight edge and compass, if we have a computer, can we figure out what the dimensions of the square is with the same area? It's not too bad, right? So in general, how do we find the height and width of a square with the same area as a rectangle?
The area square root.
Yeah, just take the square root of the area. So let's write a piece of code that does this. I'll throw some comments in here. So convert the rectangle to a square with the same area. So this is going to be public. It's not going to return anything. Okay, we're not asking for the value of something, so it's going to be a type void. And I'm going to call it SquareMe. And we're not going to pass it any arguments, because all it needs to know is the width and the height, and it's already got that because that's part of the class. So first thing we need to do is find the area. And then we need to take the square root of that, and we can do that with math.squareRoot.
Couldn't we also call area within the function?
We could, and we will. And that's a beautiful thing. All right, so math is a totally separate class. It's provided for us. It always exists, and we can get to different pieces of code inside there by saying math.squareRoot. So I'm going to set len equal to math.squareRoot of a, and then I'm going to say height equals width equals len. And that's going to be our SquareMe function. So are people here familiar with the idea of Camel Case and Snake Case? Okay, so you tend to see Camel Case in Java. Classes we mentioned the other day begin with uppercase letters by convention. Other things begin with lowercase letters by convention. So when you camel case a variable name or a function name, usually it starts with a lowercase, and then you uppercase like the first letter of each word if there's multiple words to your name. It's just convention. Yeah?
Does it matter what order you put the height, width, and length in?
In that assignment statement?
Yeah.
No.
Okay.
So like C, you can say A equals B equals C equals blah, and everything will get set equal to blah. Okay, but you cannot do that in an if statement. You can't say if A double equals B double equals C. All right, so there's a SquareMe function, and it doesn't take anything, it doesn't return anything, but what it's going to do is it's going to change the values of those class variables height and width. So let's do that. And let's get rid of R2. Let's get rid of so let's just say R1 dot SquareMe. And then let's see what the new height and width are. So we'll make our original rectangle an 8 by 2. So original rectangle is 2 by 8. We call SquareMe, and now it's 4 by 4. It works. Life is good. So yes, we could multiply the width by the height to find the area, but in fact we already have a function for finding the area. It's called area. We can just do that.
You just get rid of A and put it within
Or I could just do that. Or I could do this. So what's happening here, when we say r1.SquareMe, it's going to hop into this code. It's going to call r1.area, right, which is going to look at r1 height and r1 width, multiply and return that, pass that to the square root, and then reassign height and width to be equal to that. And that will turn our 2x8 into a 4x4 again.
That's very self-contained.
That's encapsulation, right? It's self-contained. It's got all the stuff right there. And this is so much fun to work with. Once you start building up like large complex classes, but you've got all the pieces right there, and you can bundle them together, and then you just have this class that has all the parts and pieces. So here's my linked list class, and it's got the stuff for initializing and adding and searching and stuff like that. And now I can just have a variable, L, and L is a linked list. And if I want to traverse, I can say L.traverse. And if I want to delete, I can say L.delete, parentheses, the thing I want to delete. As opposed to calling some delete function that I pass L to, and so on and so forth. So this is part of the idea of object-oriented, right? It really supports code reuse. It supports the idea that somebody else has written a package for linked lists or trees or hashes or rectangles or whatever. You don't have to keep reinventing the wheel. So if you want to write some code that, you know, helps you figure out, looks at your class schedule and tells you how you should walk from class to class based on graph theory, Dijkstra's algorithm, and traffic analysis, you don't have to spend your first few days writing a graph handling package and a linked list package and a hash package and all this stuff. You just grab this stuff and use it, right? So it's like Lego Mindstorms. You've got a block that has a processor. You've got a block with a motor on it, right? And you put those together and you build something more fun from there. And it's kind of the extreme opposite end of what we do in 270, where it's like, here's a PIC processor. I have to tell it how to turn on that motor? What? All right, so another part of object-oriented methodology is information hiding. In the case of stack pointers, this was the idea that we didn't want the person to be able to monkey with the stack pointer directly, because maybe they don't know what to do with it. Maybe they don't know if they should increment it or decrement it. Or if it's 0, does that mean the stack's empty or does it mean it's full? And so we can make things private. And as soon as we make like a field private, outside code can't access it. And we don't have separate read-write controls. If it's private, that's it. You can't read it, you can't write it. And why would we want to do this? Well, for example, suppose we don't do this. And suppose I'm being smart and I set the height of my rectangle to -2. Well, that compiles. Well, what did I do? Say what?
You completely deleted width and height, so it doesn't know what it is.
Did I?
Within the rect class.
Oh. That was a bad move.
Square root shouldn't work either.
Square root shouldn't work. So I squared my rectangle and now it's got nans for height and width. Do you know what nan is?
Not a number?
Not a number. So I just messed up my rectangle. And that might cause other problems. I might have written other things in my code that assume that height and width are not nans, right? And all kinds of weird things could happen now. So I'm going to make these things private so that somebody outside can't come in and just give them a random value. But we do want the person to be able to somehow set the width and height of a rectangle. Otherwise, this is not a very useful class. So how can we allow the main program to change the width and the height of a rectangle if we make those things private?
Inputs of some sort.
Something like inputs.
Accessors and mutators?
Accessors and mutators. So what does that mean? That is the answer.
Accessing information or?
So who has access to the height and the width?
Right.
Yeah, code inside here has access to it. They're private, so anything in this class can touch them, but nothing else can. So whatever is going to set the height and the width has got to be inside this class. So we're going to write some code. So accessors and mutators. Or you can call them getters and setters. So my first setter is going to be something called set height. And it's just going to set the height equal to whatever the argument is and return. And my set width is going to take an argument and set the width equal to that. So now I can change the height and the width by calling set width, set height. And if I want to read those, I'll make some getters. It doesn't take an argument and it returns a double. Alright, so there's a pair of accessors and a pair of mutators. And now these things are private. And if I try to modify them from main, I will get tons of errors. But I can set the height and the width using those. And I can read the height by saying get height. And I can read the width accordingly. And so we're back in business. But the advantage here is when we set the height and the width, we can do something like the following. We can say if the height you're setting it to is less than 0, ignore the request. That's not very good. We should probably print an error message or something. But for now, we'll just ignore it. And so now if I try to set the height to be -2, it'll ignore that, which means the height will end up being 0, which is a little weird, but so if you want control over how different fields are adjusted, right, you can put that in your setters and getters. And you can say, okay, so you're trying to do this, and you can either let that happen, or you can modify what's going to happen, or put out an error message, or whatever is appropriate. But now nobody can touch the height and the width of the rectangle unless they call my set height and set width functions. And those functions can do whatever we want. All right, so terminology. Functions in Java are called methods. So we don't actually use the word function, we use the word method. I don't really know why that is, but it's been really hard to say function instead of method all this time. So our main class has a main method called main, and our rectangle class has a few methods. One is called area, one is called SquareMe. So that's just lingo.
Is it common to make a lot of the functions public?
Yeah, most of these functions are going to be public unless it's something that you only need internally. So, you know, if I never believed that anybody was ever going to care about the area of the rectangle, I might make that private. Or if I was doing something that just wasn't useful to the outside world, or maybe even potentially dangerous, if it's done at the wrong time, I would make that private. And in practice, you know, you can make everything public, and if you're the only one using it, it doesn't do any harm, but it's good practice to try to be clean about how these permissions are set. Well, okay, so every time that we create a rectangle, probably one of the first things we're going to do is call set width and set height to set up some dimensions for this, because a rectangle without dimensions, it's going to be a 0 by 0. We could put in some other default, but usually you're going to want to specify the dimensions of it. And right now, every time we say new rect, we've got to follow that up with a set width and a set height. It would be kind of nice if we didn't have to do that. It would be kind of nice if we could do something like this. If instead of just constructing a rectangle, we could say, and I want that rectangle to be 2 by 8. And we can do that. So we can create what's called a constructor. So constructors are things that are called when you're trying to construct or create or instantiate an object. So here's how we define a constructor. It's going to be public, and it's going to look like a method, like a function, but it's not going to specify a return type, a variable. And that's how you know it's a constructor. And it's going to have the same name as the class itself. So this is going to be something that looks like a method called rect, but it's not going to say void rect or double rect or anything like that. It's just going to say rect. And so that makes it a constructor. After that, it just looks like any other function, any other method. So this is going to take two arguments, h and w. And it's going to set height and width equal to those values, and that's the end of our constructor. So now I can compile and run, and there's our 2 by 8 rectangle again. And we got that by just saying R1 equals new rect, 2 comma 8. So let's make R2, which is a new rect, and let's not initialize its dimensions. And when we try to compile that, we get an error. And it says constructor rect cannot be applied to the given types. So it's complaining about R2 equals new rect paren, and this always gives you two lines. What does it require you to have? A pair of doubles. What did you actually give it? No arguments. That's a mismatch. Okay, so actual and formal argument lists differ in length. So this is telling you that when you call this constructor, you got to pass two doubles. Well, maybe I don't want to pass two doubles all the time. Maybe I do want a default constructor that gives me a 1 by 1 rectangle. So I'm going to make another constructor. So now I got two different constructors, one that takes a pair of doubles and one that takes no arguments. And the one without arguments sets the width and the height to 1. And that compiles just fine. So there's a few things going on here. The strangest thing is we have two functions with the same name, and they do fundamentally different things. The first one takes a pair of arguments and sets the height and width equal to those. The second one just sets height and width to 1. But they're both called uppercase RECT. So here's another concept. In C, you identify a function by its name. If you have a function named rect, that's the function. And any time that you call something with the name rect, you're calling that particular function. In Java, you can have multiple functions with the same name. So there's a concept of a signature, which is the name plus the types of arguments. So we can have 5 different functions with the same name as long as they take different types of arguments. And that means different numbers of arguments possibly also. So our first constructor took 2 doubles, our second constructor took no arguments. I could make another constructor which I use to construct squares. And now if I say rect R3 equals new rect parentheses 2.5, it'll make a 2.5 by 2.5 rectangle.
But it would be a problem if you called just rect as a function of itself.
What do you mean as a function of itself?
Inside class rect, you call class rect.
There's ways to do that. So you can use one constructor as part of another. But it gets into a little bit of weirdness. But yes, you can do that. All right, so signatures apply not just to constructors, they apply to any method at all. So I could have, well, I don't have anything here that's particularly useful in more than one form, but I could have something that calculates area and it takes no arguments or takes 1 argument or takes 2 arguments or whatever. So signature is a more general concept than just the name of a function. And functions are identified by their name but also by their argument lists. Okay, the names of the variables don't matter. Right, so here's another constructor and my argument is called haha instead of side. That's the same signature as the first one. Okay, it's going to say that's already defined because I defined something rect that takes an argument of a double. But if I were to change this to an integer, right, that's a different signature. So now I have 4 constructors. No arguments, 1 double, 2 doubles, or a single int. And that's potentially pretty powerful. So let's reconstruct R1 as a new rectangle of length 5. So it's a square. Whoa. Pretend you didn't see that.
You can give it an int, but your int doesn't do anything right now.
Oh, thank you. So I'll give it a 5 dot to make it look like a double. That would have been a really good example if I didn't act like I didn't know what was going on. But it's still a good example. All right, so we constructed it with a single argument, and so it became a 5 by 5, and then squaring it left us with a 5 by 5. Not terribly surprising. So here's a question. Originally we said R1 was a 2 by 8 rectangle, and that does something like malloc. And then we did R2. R2 was just a red herring. And then we said R1 is a different new rectangle. It's 5 by 5. It did something like a malloc. What happened to the original 2 by 8 rectangle?
I'm hoping it was free.
Yeah, so it's a memory leak, right? Because we allocated space for this original 2 by 8, and the thing that was referring to it was R1, and then we changed R1 to be something else. And so this is exactly like, you know, P equals malloc something, and then do some stuff, and then say P equals malloc something. And if you valgrind this, it's going to say you had a memory leak, right? Unless you freed this before you changed P. So do we have a memory leak? No, we don't, because it's Java. So Java has what's called a garbage collector. And the garbage collector basically runs periodically in the background as part of the JVM, and it looks for things that are basically lost. And it'll say, hey, here's a 2 by 8 rectangle that nobody is referring to anymore. There's no reason for this thing to continue to exist because nobody has access to it, and it'll free it automatically. So that's kind of nice. It lets you be really, really sloppy with these things. And by and large, that's okay. Now, production system with a lot of stuff happening, you probably don't want to be too reckless about it. But the garbage collector is pretty efficient in practice. So we can kind of forget about memory leaks. But, you know, I would never have a reason to do what I just did up there. Because if I want rect to become a 5 by 5, I could use set width and set height and change it to a 5 by 5. Or I could make another method to say, you know, set it to be a square with this dimension, and so on. So memory is a little more forgiving. So questions up to here. Other questions? Is this making some sense?
I think so.
It's really, it gets to be a very natural way to think about coding once you sort of get to the other side of things. And then it feels very sort of hindered to go back to something like C or assembly language, where you just kind of have all this stuff and you sort of grab the things you need and put them together. The bundling of everything really makes things a whole lot more fluid in some way. So Java comes with a whole bunch of classes predefined. And the first class we want to look at is called string. And I told you that strings are built into Java, and when you declare your main method, you say string bracket bracket args. And it's just like saying an integer or something. It's a built-in, but it's actually a class. And when we say string args, it's like saying rectangle args. Okay, we're saying this is an object of type string in this case. And once you have an object of type string, it comes with a few methods, these, that you can use to do things to that string. So for example, if I have a string and I want to know how long it is, I can say string.length. And that'll calculate the length of the string and return the integer. Or I can say is empty, and it'll tell me if the length is 0. Or I can say last index of and give it something in quotes, and it'll tell me the position of that quoted thing inside the bigger string. And if it's not part of it, it'll give me a flag. Or I can say matches and I can give it a regular expression. Remember regular expressions? So I can put in a regex and it will tell me whether or not the string matches that pattern. So strings are much more than just a collection of characters that we can pass to Println, right? They're a whole class. And when we define something to be a string that contains the letters hello world, yeah, it's got the value hello world, but it also has dozens of functions, methods associated with it that we can use to interrogate and manipulate that string. And it's like it's a piece of that variable. And so there's tons of stuff in here. There's ways we can access individual characters. So remember, strings are not arrays of characters. We can't say string bracket 5. But if we want the 5th character, we could say name of the string dot character at parentheses 5. And it'll give us the 5th character. We can concatenate strings. We can do that with a plus sign also. We can see if 2 strings are equal. If a string ends with something, we can do all kinds of formatting. You can find hash codes for strings. That would be nice on a test. Index of other strings. Is the string empty? What's the length? Match a regular expression. Replace a sequence of characters with another sequence. Split a string at certain delimiters. So if you have a string with a bunch of spaces in it and you want to split it into an array of strings where each element contains, one of the things separated by a space, you can just say split. And you say split parentheses quote space, and you get back an array, and each element of the array is one of the words in your string. So eventually we're going to go back and we're going to write something like our word index program from 224. And it's going to be a whole lot easier in Java, because a lot of the struggle that you have in doing something like a word index in C is these kinds of behaviors, looking for something, splitting something up at a certain point, and so on and so forth. And these are all sort of built in to the string class. Converting to lowercase or uppercase. And the one I want to start talking about tomorrow is this thing called toString, which converts the string to a string while the string's already a string. So it doesn't really do much in this case. But toString is a really powerful function. So we'll start talking about that tomorrow and we'll see what this does for us. And it's really cool. So you gotta wait 23 hours for it, but it'll be worth it.
Are those bottom things like the scanf options?
These?
Value of
Yeah, so we can pass this a double and it'll give us back a string that looks like the double. And there's also everything's a class, so there's an integer class, right? And the integer class includes something called parseInt. And so we can do the other direction. We can pass it a string that contains an integer. We can say parse this, and it'll give us back an int. And this goes the other way. It takes an integer and gives us a string.
The Java has a friend class here.
Has a what class?
Friend class.
Yeah.
C++. The
Ye-
Java has a friend class for the private functions.
Yeah, package, I believe. You're talking about who can access?
Yeah, can we declare a friend class?
So if I understand what a friend class is, or if I'm guessing correctly, I think you're looking at protected. So
Okay.
private is just within the class, public is everybody, protected is anybody within the same package, basically. So we'll dig into that, or I can look it up later. All right, so we'll continue with strings. We'll look at toString tomorrow, and that will give us everything we need to start talking about PA1. So we'll start getting into PA1 tomorrow, definitely by Friday.
Okay.
All right, so I'll see you tomorrow.